Okay, welcome back to Unit 3, Lesson 5 now. So we're almost halfway through the unit. We're halfway through the first part of the unit, the 3.1. So that's awesome. We're getting closer there. We're figuring out lots of good stuff about genetics and cancer. Okay, so in Lesson 5, we are going to figure out how cancer cells end up with differences in their chromosomes and what the role of p53 is in preventing those differences. Okay, sorry. All right, so we're going to start like we have in the past couple lessons with our learning intentions and success criteria. Again, so our learning intention, what we're figuring out is that DNA replication can result in differences in the DNA, which can lead to cancer. So that's saying as I replicate DNA or make new versions, new copies, there can be differences in the DNA as a result of that process. And those differences can lead to the development of cancers. Okay, so success criteria. By the end of the lesson, we should be able to explain how non-cancer cells end up with differences in their chromosomes and what the role of p53 is in preventing those differences. That's our lesson question just restated. Now, breaking that into smaller chunks of things we should be able to explain. What chromosomes are made of, okay? What is a chromosome? What is it made out of? How are mutations formed? So how do I get mutations? And, probably what is a mutation and examples of those. What does p53 do to mutations, or to how do they change the interaction between mutations? And does p53 always do that? Is it always doing its job? Okay. So we're going to start off with kind of our initial ideas again and a little bit of review maybe for you. What do you think? And when we get here, you're going to pause the video and turn and talk to your group members about the two questions up on this slide, but I'm just going to kind of give you a preview of them. What do you think chromosomes are? What is your current understanding of what they are? Okay. And then what do you know about them? So what is your current understanding, your current knowledge base of chromosomes? So go ahead and pause the video and kind of think about those questions, talk about those questions with a table partner or group member. And then coming back, okay, so some things I want you to kind of think about when you're thinking about what chromosomes are, right? Like we said before, what are they made of? What do they look like? Where are they located? What is their purpose? Kind of what are all of those things that they do that you can kind of think of as things to help you as you're thinking about what chromosomes are? Okay, and we've probably heard of them before. You might be a little bit familiar with what they are, and where they're located. If not, again, that's why it's important. Talk to your group members, come to kind of a consensus, an idea about what the chromosomes are and what they do, what their job is, what they look like, all of those things. And then, yeah, just generally, what do you know? Just generally, what do you know about them? What of all of those things do you know? What have you heard about what they do? Why are they important? Why do teachers, especially biology teachers, spend so much time focusing on chromosomes? Okay, cool. So once we kind of had those initial ideas down, and again, it's initial ideas. So if we're not super confident in that at this point, that's okay. We all kind of start where we're at. We're going to meet you where we're at, and then we're going to figure it out from there. And then that's why it's important to share with those group members, because people in your group might have a deeper understanding of this than you, and you might have a deeper understanding than them. So just share that information. Okay, so we're going to hop back all the way to the cell game in lesson 3. Okay, and we're going to think about and remember back to that. And you might have to pull up that handout. It just depends. But how did the chromosomes of non-cancer cells compare to each other at the end of mitosis in day 1? So in the cell game day 1, right, that was non-cancer cells. This non-cancer cell, right, and it goes through this process and it divides. And then how are the chromosomes compared to each other? And this you are recording in the student activity sheet. So right here up at the top in that box, you're going to write that answer. And if you hopefully remember or can think about these squiggly lines in here, right, are my chromosomes. So compare at the beginning to the end, and then at the end, compare the two cells that were made. How are their chromosomes comparing? So take a moment, think about that, and then jot down your ideas, or type down your ideas on your handout, your student activity. And oh, sorry. Okay. Now, A similar thing, but we're going to look at cancer cells. So, how do the chromosomes of the cancer cells compare to the non-cancer cells at the end of mitosis? So this was day 2, right? Day 2 of that board game is where I really got some cancer occurring as we went through. So again, you can see I start with this one cell, and these are its chromosomes, and then it divides into 2. One of them has cancer, okay, and one of them does not have cancer. So looking at those, what do you think the differences in the chromosomes are? And like literally just look at this image and what's different. Look at the squiggly lines and tell me what's different about those chromosomes. And then why do you think they are different when you identify that difference? Why do you think that difference is there? What is that difference representing? Okay, so take a moment and jot down your ideas, type down your ideas about that in that student activity sheet. That's the second question on there. Okay, and then coming back, and we're going to start, and I want to just initially, kind of like my little dude here is doing, I want to just think about what makes chromosomes different, or those chromosomes different. So what makes the non-cancer chromosomes different than the cancer chromosomes? So just take a moment. You can pause the video and you can think about it. You're not going to type anything at first. I just want you to think about what makes them different. Okay, and coming back after thinking about that for a minute, about what makes them different, looking back at what you answered and what you said, what about the chromosome is different? First off, like what did you identify as the difference? And then let's kind of dig into what that really represents. Because, right, all I've got to help me before is just that squiggly line that's got something different with it than the other squiggly lines. But now let's think about actually in our cells and in our bodies, that cancer chromosome, right? The chromosomes of a cancer cell. What do you think is literally different about them? What do you think has occurred that makes that chromosome different than the other chromosomes in the cell? Okay, so like again, do you think they look different? Do you think they function differently? Do you think something internally is different? Something externally is different? What do you think is different about those cancer cell chromosomes? And make sure, like I said, you jot down those ideas in that student activity sheet. Okay, so now to kind of investigate this further and to get a better idea, better understanding of these chromosomes and what's different about cancer and non-cancer chromosomes, we've got another computer simulation, just like we did in last lesson. This one's very similar. It's just got a couple of tweaks to it. So what you're going to do is anytime you see the pink with the underline, it's a link. So if I click on this link, it's going to take me to the computer simulation. So it'll first take me to the OpenSciEd page, right? It's going to take a while to load. Look for the circle loading ring of death up in the top. Once it's loaded, then you should have this orange button here. Okay, if the orange button doesn't show up immediately, don't freak out. We don't need to like reload the page a bunch of times. Just let it load. It's going to take some time. And then you're going to click on the View Simulation button on the OpenSciEd page, and that's going to bring you here. Okay, so now in this little yellow highlighted box, it gives you the same exact instructions as the instructions on your activity sheet. So you don't need to use this really at the same time as long as you follow along with these instructions. Okay, so I've already done the first 2 instructions, which is just click Setup Reset and then click Go/pause, right? And now you're at the same point as me once you've done those 2 simple things. Okay, then you're just going to read through these instructions and it's going to tell you what to do. Okay, so if we look at this one, the DNA must be unwound. Different structures in the cell help coordinate this process. You will need to do this manually by clicking on the light blue center. So I find this and I'm just going to click on it and it will unwind my DNA. Boom. Okay, and then that little thing drifts off into space. Okay, and then just follow these instructions again. The DNA needs to be unzipped. The helicase structure in the cell helps facilitate this. You'll need to do this manually by dragging and dropping a molecule of primase onto the left end of the DNA. Primase is the same thing as helicase. So I need to grab helicase, which it can be kind of hard to grab. It's just kind of drifting out there. And I'm just going to drop helicase there and then watch as it unzips my DNA. You can notice my DNA kind of looks like a zipper as it's unzipping that. Okay, and just kind of wait for it to do its thing. You can speed up the model speed up here at the top if you want. I would keep it at the middle until you feel more confident. And then if you feel confident and you're like, wow, this is taking forever, then go ahead and speed it up, but keep it in the middle for now. And then you're going to follow along with the rest of the instructions where you're grabbing and lining these up. I'm not going to go through that with you because, you can do it at this point, but just know you're going to need to grab these things and line them up with their corresponding molecule on the DNA strand. So follow along with the rest of these instructions here. Like I said, I'm not going to walk you through all of these instructions in this video. It can be kind of hard to drag and drop. It is going to be a little bit time consuming, a little bit frustrating. I understand. I already went through the whole simulation. I get it. Okay, but I do think it's a valuable resource, and I do think it will really help us visualize what's occurring when I'm making new copies of DNA. Okay. And then you will be able to calculate percent substitution. So number of substitutions over total number of pairs made times 100%. That information comes here, correctly paired substitutions, correctly paired substitutions. So I'll get my number of substitutions divided by my number of total pairs made, excuse me. Okay, and that will get me, and I can do that here. Number of correct pairs, so you're just filling in this data table from that. And then that finishes up all that we're doing with that simulation. With all of that done, the simulation completed, those tables filled in on my student activity sheet, that means I'm now ready to make sense of what we just found out during the simulation and what that simulation is showing us. Okay, so I would work on these together with your group members. And then this is something we're going to talk about when I come to your small group or when we're in small group, just kind of making sure we all figured out the correct things. You don't need to do this alone in isolation. You're more than welcome to work with your group members to fill these questions in. But I'm just going to kind of give you some helpful prompts I think I have to help you and guide you along in developing or answering these questions. So right off the bat, what happened in the simulation? You're going to need to actually go back, right, either to the simulation itself or to here and look and see what occurred as I went through the simulation. So how many substitutions were there? What was the percent substitution? Okay, what did P53 do? How did it help change those substitutions, right? What actually literally occurred? Okay, how did the letters fit together? So again, looking back, and it'll probably be most helpful to come here. What do you notice is a trend about how all of these letters fit together? And we should notice a very defined trend of this letter goes with this letter. This letter goes with this letter. Okay, should be very apparent. Did the correct letters always go together? How did you know? So look back, was it always the correct letters pairing together and the correct pairings? And how do you know? What identified that for you? And that is one thing that we did identify here, right? When I talk about a substitution, what does a substitution mean? Okay. So just, did it always happen? Maybe, maybe not. And how do I know? How did I identify when it didn't happen correctly? Okay, what did you do when there was an incorrect pairing? So looking back when we had that incorrect pairing, what came along and kind of did its job and took care of that for me? So if I noticed that there was an incorrect pairing, what did I drag and drop, and what did that do, and how is that helpful? And then at the end of the simulation, what was the result? So at the end of the simulation, right after I've gone through and I've made my DNA strands and I've thrown P53 in there, what happened? What was the end goal? Okay, how did that help us? And how does that help us understand better what P53 does and what chromosomes do? Okay, so now I feel like we should have a pretty good idea of the differences in, maybe not the differences in cancer cells and their chromosomes just yet, maybe not that, but for sure the role of P53 in preventing, oh my goodness, excuse me, sorry, differences. Okay, so we're going to develop something for the first time that we've never done this before. This is the first time. Got to have it checklist is what we're going to call it. This is a checklist of things I need before I'm going to explain a phenomenon. So at the end of this lesson, we're going to be explaining the two things I have up there on the slide. You're going to explain to me how non-cancer cells end up with differences and the role of p53 in preventing those differences. So you're going to write me out a full explanation. Okay. And so to do that, we want to create a checklist of things that I need to have included in this explanation and evidence I already have collected to support that explanation, and maybe evidence that I still need to find to support that explanation. So what we're going to do is we're going to go back to this activity sheet and we're going to look at this got to have a checklist section right here. And I've given you the important elements I'm telling you I need represented. So these are all things I'm checking are in your explanation. I'm giving you those. What you're filling in is evidence you have supporting or explaining the relationship between DNA and chromosomes. So what evidence do I have in any of the lessons, all the way back from the very beginning, that explains the relationship between DNA and chromosomes? And then what is the source? So if this is the lesson 2 activity sheet, if this is your video, if this is this reading, this model, what is it? Okay. And if I don't have evidence or I don't have a complete amount of evidence, then I write down, well, I still need to know this about it though. So I know the relationship between DNA and chromosomes. I know that DNA is what chromosomes are made of. Okay. And my source is whatever my source is. My evidence I still need, I don't know how differences arise in DNA. Okay. So I need to find that. And so you're going to go through and based on your current understanding right now, fill in all of these. Okay. And some of them we might not have evidence for yet. So some of them might just be evidence I need to collect. Okay. Cool. All right. So now that you've done that, you filled in that evidence that you have, I have some more evidence for you to hopefully give us all the evidence we need to be able to explain what's occurring and explain our lesson question. So if you click on that link again, it's going to take you to our reading here. I do also have a class copy. This reading is all about DNA and chromosomes. It's going to have a couple of paragraphs and some diagrams for you describing DNA and chromosomes and DNA replication in some greater detail for you. So you need to definitely make sure you go through and read that. If it helps you to read it with a group member, read it with a group member. If you'd rather read it alone, read it alone. Just absolutely 1000% make sure we read the reading. Okay. Don't skip the readings. You're going to put yourself in a bad situation if you skip the reading. So read through that on DNA and chromosomes. Again, looking for the evidence. You're trying to find evidence of these things to help you better explain these aspects of DNA replication in chromosomes and cancer. All right. So now, if you didn't, I mean, I would just, as I read, revise it as I go. But if you didn't do that, then go back and revise that checklist now. So now you can go in and add more information, more evidence you have, new sources, right? That reading. And now maybe or hopefully I don't have any evidence left that I need. So what I can do is I can go through and not delete that, but maybe like highlight it yellow to say that, no, I have that now. Okay. Just so I can still see that you did record evidence you needed, but then like the highlighted yellow means that I've got that evidence now. I don't need it any longer. Okay. Cool. All right. And now with the completed checklist, what I'm going to tell you to do before you construct your explanation is I would check that checklist off with me. Okay. You want me to look at it and tell you that that is perfect, that that's got everything it needs on it. Because if I construct an explanation with incorrect evidence and incorrect information, I know that my explanation will not be correct. So before you even start trying to put all of this together into a explanation, make sure your checklist is good and checked off by me. Okay, so just have me glance at it. I will let you know if you're missing anything and if there's anything I think you need to revise. Okay, and then there's also notice and wonders here from that reading that you can fill in. That will also just kind of help you complete this checklist. Okay, so now in our explanation, you are going to, like I said before, explain how cancer cells end up with differences in their chromosomes and the role of p53 in preventing them. These are the elements you need to include. These are the same elements that I had up here. Okay. These are sentence starters to help you in developing your explanation. Your explanation for this assignment is going to be like a typed, written out explanation. So it's like an essay. I would say it's more like a CER. If you've ever heard of CERs before, stands for claim, evidence, and reasoning. So what you're going to do is you're going to provide me the claim. of how cancer cells end up with differences in their chromosomes and the role of p53. So I would probably have two claims. I'd have cancer cells end up with differences in their chromosomes by and how. And then I would have the role of p53 in preventing those differences is this. And then below that, you're going to include all the evidence, and you already collected all of that. So then, using all of the evidence you've collected, you're going to just kind of explain or elaborate on the claims that you made about how there are differences in the chromosomes of cancer and non-cancer cells and how p53 prevents those differences. And then here you've got some resources that you can use to help you. Use that computer simulation, definitely use the DNA and chromosome reading, and then that checklist we came up with, your sentence starters that I've got on that handout, any of your other lessons are great resources to help you in developing and constructing your explanation for these things. Awesome. Okay. Then, so we're going to do that on our own first. So you're going to develop your own explanation. Okay. Once that explanation is done, you're going to find another person in your class that has also written an explanation, and you guys are going to look at each other's explanation, and then you're going to provide each other feedback. So you can grab a sticky note, you can grab a half sheet of paper, and write this down. And these are some sentence starters to help you in providing them feedback, right? We want to provide constructive feedback that's going to be beneficial. And so these are some sentence starters I would use. You have good evidence to support this. It would be more complete if you added this. So we're highlighting a good, right? And then we're giving like constructive, this is something you could add, okay? You could also say, I agree that blank, I think you should add more evidence from blank. Again, highlighting something good, giving them something to work on. And then, did you include all the important elements blank? Like, are there any elements like this that I think that you're missing? Okay, and hopefully by the end of these revising and providing feedback, we're getting the best explanations possible and using our peers as the amazing resources they are to help us develop the best explanation. Okay, so like this just says, go through, review the feedback that you received and that you got from your peer, and then revise your explanation. So take that explanation that you had originally, add things, remove things, change things, do whatever you want. And just because someone gave you feedback doesn't mean you have to use it, right? If you don't agree with what they're saying, you don't have to change anything. But it would most often, I think, be beneficial. Okay. Once that is done, you are going to turn in that initial draft with the peer feedback and revised explanation. So you're going to have this bottom section completely written out, completely done, ready to go. You've added all the feedback, everything else, you can turn it in.